Hi children, Dilip Bhatnagar here. I hope you all have seen my previous videos on integration. The first video was on Introduction to Integration, in which I listed the elementary standard integrals and explained some basic integral problems. The second video was on integration by substitution technique, and the third was on integration using trigonometric entities. The fourth and fifth videos were integration of some particular functions. Now I am going to explain integration by partial fractions. I have divided this into two parts. In this video, that is the first part, I will explain integration of proper rational functions using partial fractions. And in part 2, that is the next video, I will explain integration of improper rational functions using partial fractions. We know that a rational function is a ratio of two polynomials and is in the form p of x divided by q of x. Here, p of x and q of x are polynomials in x and q of x is not equal to 0. A rational function may be a proper fraction or an improper fraction if the degree of the polynomial at the numerator, that is p of x, is less than the degree of the polynomial at the denominator, that is q of x, then the rational function is called a proper fraction. Otherwise, it is an improper fraction. Let us consider a few examples to understand the concept of proper and improper fractions. Now, if I have a rational function in the form of 3x minus 2 divided by x minus 2 whole square, here the degree of the polynomial at the numerator is 1 and at the denominator it is 2. Therefore, this is a proper fraction. Let us consider another. Suppose you have x cubed plus x plus 1 divided by x squared minus 1. Here the degree of the polynomial at the numerator is 3 and at the denominator it is 2. Therefore, this is an improper fraction. Let's consider one more. Suppose I have it as x squared plus 1 divided by x squared minus 5x plus 6. Here the degree of the polynomial both at the numerator and the denominator is 2. Since the degree of the polynomial at the numerator is not less than that of the denominator, this is an improper fraction. If a fraction is improper, it can be reduced to a proper fraction by the long division process. The improper fraction can then be rewritten in the form p of x divided by q of x is equal to t of x plus p1 of x divided by q of x, where t of x is a polynomial in x and p1x divided by q of x is a proper rational function. Therefore, the improper fraction has been divided into a polynomial and a proper rational function. We already know how to find the integral of the polynomial t of x. In case of the rational fraction, we will consider only those whose denominator can be factorized into linear and quadratic functions. The rational fraction is rewritten as a sum of simpler rational fractions by a method called partial fraction decomposition. The following indicate the simpler partial fractions. Now, if the rational function is in the form px plus q divided by x minus a into x minus b, where a is not equal to b. This can be written in the form a by x minus a plus b by x minus b. Now if you have a rational function in the form px plus q divided by x minus a whole square, this can be rewritten in the form a by x minus a plus b by x minus a whole square. Suppose we have a rational function in the form px square plus qx plus r divided by x minus a into x minus b into x minus c. This can be written as a by x minus a plus b by x minus b plus c by x minus c. Now if you have it in the form px square plus qx plus r divided by x minus a whole square into x minus b, this can be written in the form a by x minus a plus b by x minus a whole square plus c by x minus b. Suppose we have the rational function in the form px square plus qx plus r divided by x minus a into x square plus bx plus c, where x square plus bx plus c cannot be factorized further. This is important. This can be written in the form a by x minus a plus bx plus c divided by x square plus bx plus c. So we should be sure that if you have any polynomial at the denominator, we have to reduce it further. We have to factorize it as far as possible. Okay, now let us consider a few examples so that this concept becomes clearer. Now the first one is I is equal to integration of dx divided by x plus 1 into x plus 2. Yeah. Now the degree of the polynomial at the denominator is 2 and at the numerator it is 0. Therefore the integrand is a proper rational function. Therefore we can use the partial fractions. Therefore now this polynomial, right, we have 1 by x plus 1 into x plus 2 can be written as a by x plus 1 plus b by x plus 2, right? Now we shall try and find out a and b. Now let us take the LCM on the RHS. So we will get this equal to x plus 1 into x plus 2. So I will get here a into x plus 2 plus b into x plus 1, and the LHS remains the same, 1 divided by x plus 1 into x plus 2. Now since the denominators are common on both sides, we can equate the numerators. Therefore I have 1 is equal to a into x plus 2 plus b into x plus 1. Therefore 1 is equal to ax plus 2a plus bx plus b. Therefore 1 is equal to x into a plus b right plus 2a plus b. Now we will compare the coefficients of x and the constants on both sides. Now the coefficient of x on the LHS is 0, so we'll get 0 is equal to a plus b. Therefore I have a is equal to minus b. Now comparing the constants on both the sides, I have 1 is equal to 2a plus b. Now putting the value of a, I have 1 is equal to 2 into minus b plus b. Therefore, I'll get 1 is equal to minus b or b is equal to minus 1, right? Therefore, 1 by x plus 1 into x plus 2 can be written as a by x plus 1. So I will get, okay, here we'll have to find the value of a. Now a will be equal to minus b, that is 1, right? So I'll get a by x plus 1. Now a is equal to 1, so I'll get 1 by x plus 1 plus, now b is minus 1, so I'll get minus 1 by x plus 2, right? Therefore, now I can be rewritten as integral one by x plus 1 to dx minus integral 1 by x plus 2 dx, right? So this can be written as, now integral of 1 by x plus 1 dx is log of x plus 1 plus c1 minus, now integral of 1 by x plus 2 is log of x plus 2 plus c2, and this is finally we have log of x plus 1 minus log of x plus 2 is equal to log of x plus 1 divided by x plus 2, right? And c1 plus c2 is equal to another constant c, right children? Now let us go into the next example. Right, now here we have I is equal to integral of x divided by x minus 1 whole square into x plus 2. Sorry, this has been written wrong. This is x plus 2. I'll rewrite this as I is equal to integral x divided by x minus 1 whole square into x plus 2. It was written wrong above. Okay, I've rewritten the sum again. Okay, now here the degree of the polynomial at the numerator is 1 and at the denominator it is 2. Therefore at the denominator it is 3. Therefore the integrand is a proper rational function. Therefore we can use the partial fractions. Therefore now x by x minus 1 whole square into x plus 2 can be written in the form of a by x minus 1, right, plus b into divided by x minus 1 whole square plus c divided by x plus 2. Okay, now taking the LCM on the RHS, we rewrite the LHS is x by x minus 1 whole square to x plus 2. Okay, now when I take the LCM, the RHS, I'll get x minus 1 whole square into x plus 2, and in the numerator I'll get a into x minus 1 into x plus 2, right, plus b into I'll get x plus 2 plus c into x minus 1 whole square. Right. Now, since the denominator on both sides are common, we can equate the numerators. Therefore, I'll get x is equal to, now let me open the brackets, so a into x square plus 2x minus x minus 2, right, plus bx plus 2b plus c into x square plus 1 minus 2x. Okay, therefore x is equal to, now I'll take all the coefficients of x square, I'll take x square common, and I'll get a, right, plus c. Okay, now I'll take the coefficients of x, so I'll get a plus here b, and here get minus 2c. Right, now I'll take the constants, so plus I get minus 2a plus 2b plus c. Therefore, now when I compare the coefficients of x square, x and the constants on both sides, I'll get, now the coefficient of x square on LHS is 0, so I'll get 0 is equal to a plus c. Now next is, okay, so I will get here a is equal to minus c. Okay, now if I compare the coefficients of x, then I'll get 1 is equal to a plus b minus 2c. Right, now, okay, now for a is your minus c, so I can write 1 is equal to minus c plus b minus 2c, so I get 1 is equal to b minus 3c. Okay, now comparing the constants on both sides, I'll get 0 is equal to minus 2a plus 2b plus c. Okay, now I will put a is equal to minus c, so I get 0 is equal to minus 2 into a is minus c plus 2b plus c, so that gives 0 is equal to 2c plus 2b plus c, therefore 0 is equal to 3c plus 2b. Right, now let me take this as equation 1, this is my equation 2, and this is my equation 3. Okay, now from equation 2 and 3 I'll get, now I know from equation 2 I have 1 is equal to b minus 3c, therefore I have b is equal to 1 plus 3c. Right, now from equation 3, putting the value of b in equation 3, I'll get from equation 3, I'll get 0 is equal to 3c plus 2b. Therefore now putting this value of b, so I'll get 3c plus 2 into 1 plus 3c, 0. So this is equal to 3c plus 2 plus 6c. Therefore 0 is equal to 9c plus 2. Therefore I will get c is equal to minus 2 by 9. right? Now from now I can get the value of b from this equation. I know b is equal to 1 plus 3c, right? So now putting the value of c, I'll get b is equal to 1 plus 3 into minus 2 by 9. So I get this is equal to 1 minus 6 by 9, right? So this is equal to, finally I'll get this is 2 by 3. I'll get this finally equal to b is equal to 1 by 3. Now from equation 1 I'll get, I know a is equal to minus c, therefore a is equal to 2 by 9. Right, children? Now let me go to the next page. So I can rewrite this as, rewrite as, right. Now what did I get? I got x by x minus 1 whole square into x plus 2. This can be written in the form by replacing ABC. I'll get this is equal to a, that is 2 by 9, divided by x minus 1, okay, plus b by, so b is 1 by 3, I get 1 by 3 divided by x minus 1 whole square, right, plus c, so c is minus 2 by 9, so I get minus 2 by 9 divided by x plus 2, right? Therefore I can be rewritten, now we know I is equal to integral x by x minus 1 whole square into x plus 2 dx. This can be written as 2 by 9, the constant, so I take it out of the integral, 1 by x minus 1 dx plus 1 by 3 the constant, so 1 by 3 integral 1 by x minus 1 whole square minus 2 by 9 integral 1 by, okay, this is dx x plus 2 dx. Okay, now this is nothing, I can write this as 2 by 9 into I1, right, plus 1 by 3 into I2, this I do for convenience, and minus 2 by 9 into I3. where I1 is equal to integral 1 by x minus 1 dx, right? I2 is equal to integral 1 by x minus 1 whole square dx, and I3 is equal to integral 1 by x plus 2 dx, right? Now let us integrate I1. Now I1 is equal to integral 1 by x minus 1 dx. So this is equal to, right, log of modulus x minus 1 plus c1, right? Now I2 is equal to integral of 1 by x minus 1 whole square dx. Now here, as we have learnt earlier, let's take x minus 1 equal to t. Therefore dx is equal to dt, right? Therefore I2 can be written as integral. Now dx can be written as dt, so this is dt by, now x minus 1 is t, can be written as t square. This is equal to integral t to power of minus 2 dt, and this is equal to t to power of minus 2 plus 1 divided by minus 2 plus 1, that is t to power of minus 1 by minus 1, and putting the value of t, okay, this is plus c. Okay, now putting the value of t, I'll get this is equal to x minus 1 whole power of minus 1, and then minus 1, this plus c2. Okay, now let's do I3. I3 is equal to integral 1 by x plus 2 dx. This is equal to log of modulus x plus 2 plus c3. So therefore now I can write I is equal to 2 by 9 into I1. I1 is this, so I'll write 2 by 9 into log of x minus 1, right? I'm not writing c1 because c1 plus c2 plus c3, I will take it as another constant c. Okay, now plus 1 by 3 into I2. I2 is here, so I can write it as minus 1 by minus 2 by 9 into I3. I3 is log of what is x plus 2. Right. Now this is 2 by 9, this is also 2 by 9. I can take 2 by 9 common. I'll get here log of modulus x minus 1 minus log of x plus 2 okay, and here I'll get minus 1 by 3 into x minus 1. Okay, plus a constant c. Right, so this will be equal to 2 by 9. Now log of x minus 1 minus log of x plus 2 can be written as log of x minus 1 by x plus 2 minus 1 by 3 to x minus 1 plus c. Right, now let us do one more example, and this will make things more clearer. Right, the next sum is I is equal to integral of 2x minus 3 divided by x square minus 1 into 2x plus 3. Right, now children, we see in the denominator we have x square minus 1, so this can be further factorized, so we must factorize this further. Right, so we can write I is equal to integral 2x minus 3 divided by, now x square minus 1 can be written as x plus 1 into x minus 1. Right, so and into 2x plus 3 dx. Okay, now I can be written, now this 2x minus 3 by x plus 1 into x minus 1 into 2x plus 3. Okay, now since in the numerator the degree of the polynomial is 1 whereas at the denominator is 3, so this is a proper rational function, so we can use the partial fractions. So this can be written as equal to a by x plus 1 plus b by x minus 1 plus c by 2x plus 3. Therefore, now 2x minus 3 divided by x plus 1 into x minus 1 into 2x plus 3 can be written as, now here I will take the LCM, so I'll get x plus 1 into x minus 1 into 2x plus 3 So here in the numerator I'll get a into, now since x plus 1 is already here, I'll get x minus 1 into 2x plus 3, right, plus b into, now since I've already got x minus 1, here I'll get x plus 1 into 2x plus 3. Yeah, x plus 1 into 2x plus 3 plus c into, since 2x plus 3 is already there, I'll get c into x plus 1 into x minus 1. Okay, now since the denominator on both sides are the same, we can equate the numerators. Therefore I'll get 2x minus 3 is equal to, now I'll open the brackets, I'll get a into, yeah, 2x square plus 3x minus 2x minus 3, right, plus b into 2x square, okay, plus 3x plus 2x plus 3 plus c into x square minus 1. Therefore 2x minus 3 is equal to, now this is equal to x square into 2a plus 2b plus c, right, plus x. Now write all the coefficients of x. Now 3x minus 2x is x, so I'll get a plus 2x plus 3x is 5x, so I'll get 5b, right. Now plus I write all the constants. Here I get minus 3a plus 3b minus c. Okay, now I will compare the coefficients of x square on both the sides. Now on the LHS, the coefficient of x square is 0, so 0 is equal to, yeah, 0 is equal to 2a plus 2b plus c, right. Next, so here I can write c is equal to minus 2a minus 2b. Okay, just let me write this as equation 1. Now comparing the coefficients of x on both sides, I'll get 2 is equal to a plus 5b this is my equation 2, and comparing the constants on both sides, I'll get minus 3 is equal to minus 3a plus 3b minus c. Now putting the value of c from 1, I'll get minus 3 is equal to minus 3a plus 3b plus 2a plus 2b. Therefore I get minus 3 is equal to, okay, minus 3a plus 2a is equal to minus a, okay, and plus 5b. This is my third equation, equation number 3. Okay, now from equation 2 I get equation 2 I get a is equal to 2 minus 5b okay. Now putting the value of a in equation 3, I'll get equation yes, I get minus 3 is equal to, now a is equal to 2 minus 5b, so I'll get minus 2 plus 5b plus, so this 5b, therefore 10b is equal to minus 3 plus 2, that is minus 1. Yeah. Therefore b is equal to minus 1 by 10. Okay. Now putting value of b in equation 3, from equation 3, let me put the value of b. I get minus 3 is equal to minus a plus, so I'll put the value of b, I'll get minus 5 by 10. Therefore a is equal to minus 1 by 2 plus 3. So this I will get minus 1 plus 6 . So this is equal to 5 by 2. A is equal to 5 by 2. Okay. Now I got the value of b, I got the value of a. Now I need the value of c. So I can put the value of a and b in equation 1. I know c is equal to minus 2a minus 2b. Therefore this is equal to minus 2 into 5 by 2 into minus 2 into minus 1 by 10. So this is equal to minus 5 plus 1 by 5. And this will be equal to minus 24 by 5. Okay, now let us put the value of a, b and c in this equation. So going to the next page, I'll get I is equal to right now I get 5 by 2, it is a, that is 5 by 2 integral dx by x plus 1, right, minus 1 by 10 integral dx by x minus 1 minus 24 by 5 integral dx by 2x plus 3. Okay, now as we have done earlier, let this, for simplicity, we write this is equal to 5 by 2 into I1 minus 1 by 10 into I2 minus 24 by 5 into I3, right, where I1 is equal to integral dx by x plus 1, I2 is equal to integral dx by x minus 1, and I3 is equal to integral dx by 2x plus 3. Okay, now I1 is equal to integral dx by x plus 1, so this will be equal to log of modulus x plus 1 plus c1. Okay, I2 is equal to integral dx by x minus 1, this is equal to log of modulus x minus 1 plus c2, and I3 is equal to integral dx by 2x plus 3. So here we'll let 2x plus 3 is equal to t. Now differentiating both sides, we get 2 dx is equal to dt. Therefore dx is equal to dt by 2. Therefore I3 can be written as integral. Now dx is dt by 3, so I can dt by 2, so I can write 1 by 2 integral dt, and 2x plus 3 is t, so I can write t. So this is equal to 1 by 2 log of t plus c3. Putting the value of t, I get I3 is equal to 1 by 2 log of modulus 2x plus 3 plus C3. So finally I get I is equal to 5 by 2 into I1. I1 is log of x plus 1. Okay, I'll not put C1, C2 and C3 because I can finally write it as C. And then I have minus 1 by 10 into I2. I2 is log of modulus x minus 1. Okay, and I minus 24 by 5. I3 is 1 by 2. Yeah, 1 by 2 log of modulus 2x plus 3 plus C, right? 2 ones are 2, 12 times. So finally I'll get I is equal to 5 by 2 log of modulus x plus 1 minus 1 by 10 log of modulus x minus 1 minus 12 by 5 log of 2x plus 3 plus C. Thanks children. I hope you all have found this class useful. In the next class, I shall explain integration of improper rational functions using partial fractions. Please like, share and subscribe to the channel. To view more informative videos, you can press the bell icon to receive notifications whenever I post a new video. You can put your questions in the comment section below or email me at dlpbhatnagar@yahoo.co.in. Thank you.